So welcome everybody to this bioenergy lecture today. Our themes are today introduction to bioenergy, then a little bit of the current state of bioenergy in European Union and Finland, and about the policy instruments promoting bioenergy, which are used in European Union. Then we have feedstocks of bioenergy, about technologies converting biomass to bioenergy, use of it, and then at the end the challenges with bioenergy. So my name is Eva Hämeenmaa. I work as a lecturer in Sykli. So bioenergy, it's one of the many diverse resources available to meet our demand for energy, and so we can start with very traditional one there. This fire by the lake there, it's kind of bioenergy, and to very sophisticated and modern technology, liquid biofuels and biorefineries. It's a very vast area. So EU Renewable Energy Directive defines what is biomass, because biomass is used to produce this bioenergy, and you can read the definition there. And one thing which is very important is that we have renewable energy, and bioenergy is part of renewable energy, but it's as you see there's very many other kinds of renewable energy also available: hydropower, wind energy, solar energy, and so on. But bioenergy is one very important one, and it's also important because it's very flexible, and it can support, for example, using when we are using wind or solar energy. So this is bioenergy can be very helpful to maintain the energy system in that sense. Bioenergy is also part of bioeconomy, and there are this besides bioenergy, so these products and are very important, and in European Union's bioeconomy strategy, so there are these goals are food security, and also employment and competitiveness are very important, climate change, sustainable management of natural resources, and dependence on non-renewable natural resources. And in Finland, we have also added this ecosystem services also as part of the bioeconomy. So ecosystem services are these services which are offered to us by the nature, and we also think that that's belongs to bioenergy. And there are, as you see, so we have a food sector, we have forest sector, we have energy, construction, water treatment and supply, and bioeconomy services. So it's very diversified field, and in Finland in 2019 the share of the bioeconomy was 13% of the total our economy. This is a definition. So in different countries, this bioeconomy is defined in a bit different ways, but everywhere there's agriculture, there's forestry, and there's pulp and paper industry, and wood products industry are always there. I also added here this EU strategy for energy system integration, because these biofuels, they have an important role in those sectors where electrification is not feasible, or it's very difficult. Electrification is the main goal in this transport subsector, but it's not so easy to apply it everywhere. And also in those fields where we think that we have to quite a long time still to rely on internal combustion engines, and so on. So there this use of renewable use of biofuels is very important. Bioenergy is also a very important part of circular bioeconomy. So or circular economy and circular bioeconomy. And it's when we talk about bioenergy, it's important to understand that we have food and feed, we have these bioproducts, and we have energy, and in a way these different fields, they are competing with each other, or we have to quite often we have to choose in which part we put our effort on. So so it might be that this increase in bioenergy is not possible because, for example, because if there's a shortage of food and feed, so this whole picture is important to understand. So where does this bioenergy come from? So we have three main sources of biomass. So there's woody biomass, agricultural biomass, and waste. And as you see, this woody biomass or solid biomass is the most important, and especially in northern part of Europe. And this bioenergy is where do we use it for? So the main part we use for heating, about 70%, then for producing electricity and as a transport fuel. And in this main source, this heating, so here in heating we can use individual biomass stoves or biomass boilers, or it can be used in district heating. So what is the current state of bioenergy in European Union and in Finland? This picture is from 2016, and there we can see that the share of renewables in EU is about 17%. And if we look at how it how the situation has progressed, so in 2020 it was already 22.1%. And about this renewable energy, so bioenergy is about 60% of that, and other renewables about 40%. And then the use of biomass, bioenergy is used for this heating and combustion, bioelectricity about 13%, and transport about 12%. And because this bioenergy, we use biomass to produce bioenergy, so it depends very much on the nature, on the agriculture, on the forestry of the country. What is the most important supply for bioenergy? But as a whole, in European Union, this direct wood supply is about 40 megatons. Megatons of oil equivalent. Is I put here also this table if you want to convert this energy unit. So this is this MTOE and then terajoule and gigawatt hours. So direct wood supply and indirect wood supply, it's about 40 MTOs. Agricultural crops are a little bit less, and as well as agricultural byproducts. And waste is the small, well, about the same as this agricultural byproducts. And we can look a little bit more detail what these include. So during this from 2000 to 2019, this bioenergy use in EU has increased about 150%, and it's at least in the European Union, it's interpreted so that it's very much largely by the policy, because there has been directives and incentives for this bioenergy use, which has been launched here during this years, and so a significant growth has happened. So, and it's both in heating, industry, power, which means electricity and road transport. In northern countries, so we have here Finland, Sweden, Denmark, and Norway, and here we look up at the renewables as a whole. So this bioenergy is in Finland it's over 30%, and in Sweden very near that. In Denmark it's lower, and in Norway, as we know, this hydropower is very important there. So this bioenergy is not so significant. And in EU, it's this bioenergy is about 10% of the total energy consumption. And if we look where in this renewable energy branch, where has been which parts have the most rapid growth, and as you may know, this wind has growth has increased over 10%, and solar, the total consumption is more, but the growth is less, but the growth is more, and hydropower has remained about the same, and bioenergy has growth about with 6%. So EU has set a target for renewable energy, and as a whole it was 20%, but this common target, it was divided to different countries, and they had different national targets, and the national targets are very well. You may wonder why they are so different, and this has been done so that the countries has reported what is possible for them, and what's how much renewable energy they already have, and what they, so it is, they have influenced themselves very much what is for this target which is set for them. And in 2020, Sweden and Finland and Latvia had reached this target, and the others are still Portugal as well. So, and the others are still a little bit behind. And next year in 2020, so all these countries which have yellow text here, they had reached their renewable energy targets, and they had overachieved, and the blue ones had achieved, and red ones were a little bit below. And this looks quite good. It's France which is a little bit behind, but otherwise this renewable energy target, European Union is very well progressing in that part of this energy targets. This is also this when we look at the different countries in Europe, and what are the biomass types which are used for this bioenergy, and as you see, this solid biomass, which means wood biomass, it's the main one, and in Germany this biogas part is also quite significant, and besides this, it's also this municipal solid waste is the gray one here. Bioliquids, which are used for transport, the share is smaller, but there may be the pressure to increase that part is quite high. In Finland, these wood fuels, of course, we are the country with a lot of forests, and so this wood fuel is has always been very high in Finland, and if you look at this total energy consumption, it's almost 1/3, which is covered by wood fuels. And this wood, what is very important is black liquor. It means that it's in pulp and paper industry. This black liquor is part of the process products, and that's used for the energy production in the pulp and paper industry, but the amount of energy is so high that the industry is not using all of that, but it can also be sold to other customers. So it's a very big part of this food fuels. Then we have bark, sawdust, forest chips, sheets, and pellets. So as I already said, that this policy, these incentives and this policy using of these policy instruments have been very strong in European Union in order to increase this use of increase of producing this bioenergy. It's also that this bioenergy, it's a topic that when you read about articles and news about bioenergy, they can be very diversifying, because it depends if it is the industry, or if it is the landowner, or if it is the environmental organization, or if it is some administrative person who is writing about it. So the opinions and the thoughts can be very diversifying, and it's also that this has been an object for very strong policy instruments in Europe. So in Europe, there's this Green Deal. So there's a lot of targets for bioeconomic. So a fair and prosperous society, and resource efficient, competitive economy, and so on. And of course, maybe the most important is the climate law, and European Union was to be reach climate neutrality in 2050, and energy system should be decarbonized, and so on. So so last summer, European Union published this so-called Fit for 55. It's a set of suggestions for this climate laws, and so there the target is at least 55% net emissions cut by 2030, and in greenhouse gas emissions we want to reach net zero by 2050. In renewable energy, which is a very important part and important tool in this policy, is that now the target is minimum share of 32%, but right now under discussion is to increase this target to 40%, and this has been also there has been a lot of criticism against this change, because this 32% target was just this directive was just implemented last summer, and it was, and all the measures had been decided, and just at that point there, when it was thought that now we have a clear plan how to go on, there was a new target of this 40%, and this is now under discussion. So there is a new and well, we get the decisions, I think, probably next autumn. There's also a target for energy efficiency. The minimum improvement should be 32% by 2030. And besides this emission targets, there's a circular economy action plan. There is a farm to fork strategy. There's your biodiversity strategy for 2030, and we look at those also in more detail there in the following slides. So this Fit for 55 is there are about 12 different suggestions for this to implement this climate law. And what is maybe most important in this bioenergy is this renewable energy directive, and and this directive is about bioenergy sustainability, and it sets the rules, the sustainability criteria, no-go areas, and in this version, which is now valid, this number 2 land criteria for agricultural biomass, and in the new revision, there's no sourcing from primary and highly biodiverse forest, peatland, and wetlands. And this is in Finland also under discussion, because we have a lot of forests, and so sometimes it's felt in Finland that this pressure for protecting this forest is concentrating too much on Finland, but well, it's under discussion. Then we have application of bioenergy and this greenhouse gas saving criteria, and now right now it's applicable to heat and power installations, which are about 20 megawatts. And the saving criteria only for new installations, but in revision, also the small scale installations equal above 5 megawatts is taken there, and they are applied also to existing installations. And then there's cascading principle, so it's to minimize the distortions of biomass market, and no support for saw and veneer logs, stumps and roots, and delegated act on cascading use of biomass. And besides this renewable energy directive, there is also this land use changes and forestry regulation, and there are it's about the, maybe the most influence on the forest use, and also then in this European emission trade zero rating for biomass and biogas only if it is sustainable. So current target is this renewables 32%, and the new target is to raise that to 40. And then this sustainability, this prohibiting sourcing mass for energy production of primary forests, peatlands and wetlands, and no support for forest biomass in electricity only installations, and so on. And this is the cascading principle you can see here. So it means that the biomass should be used according to highest economic and environmental added value. So in the first place, try to use this biomass for wood-based products, which have a long life, and then try to extend also the service life. Then try to recycle, reuse, and recycle this biomass, woody biomass. And bioenergy is only here after all this material, product and material use should be prioritized first, and bioenergy use is here, and in the worst case it is this disposal of this biomass. About renewable energy directive, there's still some the details here if you want to look at them in more thoroughly. And I also added here this EU strategy on energy system integration, because now we have mostly these energy systems are linear, and there are wasteful flows of energy, and now the development is going to more integrated energy systems, and here as I already mentioned, this bioenergy is flexible, and it can used in many cases where this electrification is difficult, or and for example in wind and solar energy, the problem is that it's not always there. It's sometimes that is available, but not always. So bioenergy can also then help in balancing the system. So here I have listed about, as I said, this regulation is quite strong. Here's about 14 different directives of regulations which concern this bioenergy, and as a whole, this is this regulation 3 of European Commission. So in a way, it's, well, or in many ways, it's very good, and good results are also achieved, but for the practical operators, it's not always easy, because the regulations are so manifold, and the most criticism from industry is coming that these decisions, they change so frequently. So in order to be able to invest something, and so the industry should trust, they should have this confidence that these regulations, that they are long term, and so that the investments are done in the right place, and there are no rapid changes. So besides this regulation, of course, there are also some other kinds of incentives. So there are taxes, there can be subsidies, and there can be tradable permits and quotas, or international offset systems, and so on. And here I have also only picked some examples, because this is also a very vast area. So in bioelectricity, there's feed-in tariffs and feed-in premiums which are used, and in bioheat subsidies, and these biofuels, very often there is some mandatory blending quotas which are used. And then also fossil fuel taxation, though there are still also some support from fossil fuels remained. And what is now maybe the most important are these investments for this renewable energy and bioenergy. So that because we want this energy transition, and in order to do it quickly and efficiently, so this these investments and support for these investments are also needed from the state. Then there are some examples of fuel taxation in Nordic countries, and they they're a bit different, but this fossil fuels include both energy content and carbon content tax in all Nordic countries. And because the Nordic countries have been quite successful in this use of bioenergy, so when it has been studied that what is the reason for that, so the explanation, for example, in Finland is that these biomass resources are good, infrastructure is good, and incentives also support this use of that. And in Sweden, the result is the same. And in Denmark, only infrastructure has this very high contribution and incentives somewhat. So although we criticize a bit regulation and this complexity of the system, still the incentives, they have an important role in doing this energy transition. Then next we should look at the feedstocks of the bioenergy in the EU and Finland. So as already discussed, the woody biomass is the main one, and then agricultural and bio-waste have also some role. These potentials, when looking what would happen then in this from 2020 to 2050. So these agricultural residues are here is the forecast that they a little bit, the amount decreases. Energy crops a little bit is growing, and forest biomass also have some growth. And European Union, the total amount of biomass, now this is expressed in energy units, is 10.3 exajoules, and it is now it is divided so that this energy has 6.2, materials 4.1, and the rest is and for food and feed it's 13 here. And now very often it can be the case that this energy and materials, they are the use of energy and use for materials, they are competing with others, and in this cascading, according to this cascading principles, this material used should be emphasized. So it has influence for the amount of bioenergy in the future. This is then more detailed analysis of this current biomass supply in EU, and when we look of this bioenergy category, so industrial byproducts from forestry and construction, so there can be bark, wood chips, sawdust, and so on. Forest residuals are tops, branches, rotten or splintered trunks and stumps, and it might be that in the future, for example, this use of stumps is not allowed anymore. Then there's domestic and industrial waste, agricultural residues, food crop residues, process residues from food industry, biofuel, and biochemical production residues, and then various organic waste flows. So solid bioenergy, woody biomass, it's most used in Europe, and we can look here more. So the very traditional ones are this firewood and charcoal is most common from thermally treated woods. Then densified wood pellets and wood chips, they are used in energy production, and then this black liquor, which I think I already mentioned that it dominates the wood energy production in countries where this pulp and paper industry is significant. In Finland, this wood biomass is very important. We have small scale combustion of wood in, well, just private houses, small houses, and then we have these solid wood fuels in heating and power plants, and then these wood fuels, this black liquor is very important. Here, when we look at this progress, what has happened during the last 20 years, so this forest chips, it has increased, and also this forest industry byproducts park. If you look at the yield of different products of the forest harvested tree trunks, so this is roughly so that the building products, for the building products is used over 40%, and for the pulp and paper about the same. And for bioenergy, the share of the bioenergy, it's much less, but it's still here about, well, 10%, a little bit more. And here this Stora Enso mentions that these tree stumps and roots remain in the forest for biodiversity. So this is a change. It was previous that these stumps and roots, they also collected for bioenergy use, but now, because of this changing requirements for biodiversity, it's more common that they are remaining in forests. This is I think a nice presentation from biomass and energy flows. This is from the Swedish forest, and here we can see that this from this stem wood, so part goes this pulp wood, and parts go to the timber and sawmills, and then these stumps, roots, branches, and tops, they go to this decomposition, stock increase in forests. And if we look what are the products here, so of course we have paper and pulp here, we have wood products, and here in the from the pulp and paper and these branches and tops, we get also district heat, bioelectricity for district heating. From pulp mills, we as a side product, we can get biofuels and heating excluding this, and also other heating excluding district heat. And I think here the trend is so that the more and more we try to, the industry and also the policy tries to get more of these wood products and also the side products and biofuels, and decrease this part of this heating, and trying to utilize more of lignin and these substances of wood for more advanced products, not only for combustion. So wood removals. So this is we used about 5 exajoules per year, and upper limit is estimated to be 5.6. So biodiversity and soil health limit the harvesting, so it's not much growth available here. And residue removals is the same story, that the increased rate can risk the carbon cycle and biodiversity. And industrial byproducts. So these can also for this energy use, they can marginally decrease over time. About agricultural residues and dedicated energy crops. So this dedicated energy crops means that there are some maybe some food crops or some perennial forest crops. They are growth especially for this energy. So it can be traditional heat or modern heat, or it can be power fuels, first generation biofuels or advanced biofuels, or even chemicals and novel materials. So agricultural biomass, it consists of crops such as corn and sugarcane and beets, oilseeds, agro-industrial products, and so on. And these agricultural residues, they can also be divided so that there's these primary residues which are left in the field after for harvest or pruning, and then we have secondary residues which we get after the processing phase, for example, olive pits or nut shelling, and so more common in southern Europe, and then we have this dedicated energy crops. So certain parts like miscanthus, poplar, or willow, and they are grown specifically for their energetic value. So these agricultural residues, they are shown here. How much we have now in Europe, in different countries, and this default collection, and then also here how much would be this optimal collection. So we can see that there's a certain possibility of improving this collection and increasing this amount of available residues. But of course, there's also a limit there, so that this soil organic carbon content must be maintained. So it's all of this always when this biomass is concerned. So there has to be careful that this biodiversity or this organic stocks that they are not overused. When looking at the future, these food-based biofuels, so it's so that it's forecast that their amount is decreasing because there are quite many agricultural constraints. So that first is environmental sustainability. So climate change, it has influence on this on agriculture, especially in southern Finland, southern Europe, and also this soil quality, quantity, and water. They limit this use of this agricultural biomass, and which is very important that this competition with demand for food and feed and fibers, it's quite great, and so this bioenergy use is decreased also because of that. So right now, this in Europe, 5 to 6 million hectares is used for energy crops, and and it's about 0.8 exajoules, and in this material economics study, they say that this upper limit would be 5.6 exajoules, but then the land which would need there is 35 million hectares, size of Germany. So that kind of growth is probably not possible in Europe. So we had this woody biomass and agricultural residues, and then we have waste, and this waste to energy, it's the fourth most important category of bioenergy feedstock in Europe, and there are in 2015 there were over almost 500 installations in Europe, and about 27% went to waste to energy plants for energy use, and for recycling 30%, and to landfills 24%. And there are the countries where there's the largest household waste potentials is Germany, Spain, France, Italy, Romania, and UK, and they have large waste potentials, and they have incineration without energy recovery. So they combust waste, but they don't always, especially here the countries mentioned here, they don't recover the energy from that. So they only have the emissions, but not the useful use for that heat. In Finland, in northern countries, and also the big part of Europe, we have this landfill ban, which means that there's that organic waste has to either be recycled or it has to be combusted. But we still have here, we have our UK is not part of EU anymore, but still we have here in Southern Europe, we have big countries with no ban for this landfilling, and this means that this organic waste is not used, but it only produces methane emissions in these landfills. So this would be this would need a change in European Union, and there would be also the possibility to increase this amount of bioenergy by and decrease these methane emissions. If you look about this situation is worldwide. So in this food waste, there's a lot of that in globally available. So that would be a potential for this increase in bioenergy. It only that it needs a collection, it needs the technology, so it doesn't come free, but it needs this organization and needs investments. But if you look at this global bioenergy supply by source, and this is this looking at this no zero emissions. So the biggest growth here is in these organic waste streams. So globally, in Europe, we have a possibility to improve to some extent, but globally, there's a great possibility to use these organic waste streams for energy production. So recycling and waste For paper waste, we have a little bit potential in Europe. For wood waste, a little. For this, as we saw with the about the, for example, using with these landfill bans and so on, and other waste supply rights from better collection and better use of waste generated, this other waste can be doubled. So we need, in order to produce bioenergy, we need this biomass, but we need also the technology to convert that biomass into bioenergy. And here, this is a list of different kind of feedstocks. So we had talked about these are these oil crops. These are either residues or just dedicated crops. And this lignocellulosic biomass is this from forest, from wood. There's also straw included. Here we have this waste part, this biodegradable municipal waste. And there's also microalgae and bacteria, which we have not covered. And these are these conversion routes. So these are the technologies, and we look a little bit more detailed about this combustion, which is the most common. We talk a little bit about this chemical transesterification and fermentation, just a little bit about gasification, and the one which we look more detail is this anaerobic digestion. And so these are the technologies, and what do we get there? So we can get heat and power, we can get liquid fuels, biodiesel, ethanol, syndiesel, methanol, ethanol alcohols, and other fuels, and we can get gaseous fuels like biomethane. Also, hydrogen is mentioned here, but in this lecture we don't cover this hydrogen production. So biopower technologies, there this biomass is converted into electricity or fuels, into heat and electricity using these processes like those used with fossil fuels. So it can be this biomass can either be burned, combusted, or it can be fermented, or it can be converted to gas or liquid fuel. And this bioenergy from waste, this combustion is the most common one. And there, this municipal waste is incinerated in CHP plants, and so there both heat and electricity can be produced simultaneously, and this heat in waste incineration is can be distributed to consumers with district heating system. And district heating, of course, can also be provided through heating plants or waste heat from industries. So this waste to energy, this HEP, this is just a description of that. So in this CHP plant, so from the combustion is produced steam, and through the steam turbine we can produce electricity, and at the same time there's a production of heat. and of course then we have some wastes here. We can have some landfilling parts, and we can maybe collect some metals there, and there can be some ash, some aggregate coming from the plant. And so this combined heat and power, it's very efficient because at the same time when we produce electricity and heat, it's the use of fuels is maximized, and also the amount of carbon dioxide released can be released. So using this combined heat and power, this efficiency of fuel use up, it can be so that the efficiency is high, up to 90% of the fuels can be utilized, and compared to separate production of electricity heat, is also lower emissions, and this fuel source, it can be it's very flexible. It can be biomass and waste, so different kind of mixtures of this fuel sources. So the situation in Finland is so that because of this is the municipal waste treatment method, and this is during the last 20 years. So landfilling is the blue part here, and so this is very good. This landfilling is practically zero by now, and this energy recovery has increased a lot, and material recovery, well, it has here. There's a little bit of growth, but it's not growing very fast. The problem here is that when we look at this weight hierarchy, it's the same as we already talked about this cascading principle in the woody biomass, so that we put in the waste. So the best thing we could do is to prevent this waste from waste prevention, and then we can prepare for the reuse or recycle the materials, and only after that to recover that. And now, for example, in Finland, because we have these plants, we have a very efficient energy recovery. It seems that we don't progress fast enough in this material recovery part. So because according to the circular economy package, so 55% of municipal waste needs to be reused and recycled by 2025, and I think right now it seems that we are not reaching this goal, and after that it increases to 60 or 65%. So landfilling is that's very good, but this heat or this energy recovery should be maybe decreasing a lot, yeah, and this material recovery part to increase. On the other hand, if we look at this on the other direction, is that if we would use fossil fuels for this heat and electricity and transport, and we replace fossil fuel by bioenergy, so we can get that much savings in different sectors. And these are megatons of carbon dioxide equivalents. So using bioenergy is instead of fossil fuels is very good. But if we look at on this circular economy point of view, so maybe on this energy part, so energy efficiency or saving the energy and producing more materials, doing more recycling would be the best possibility. So because we are a little bit behind also in this our emission targets in both globally and in European Union, so we are in the situation that we have to maybe capture some carbon dioxide from the air. We have to, of course, produce it less or use this bioenergy, but also this carbon capturing and storage maybe is something which is necessary in the future. So this is only for you to this carbon capture and storage, CCS, is something which there's a well, it's important to know also when we talk about this bioenergy, if when we do this carbon capture and storage together when using bioenergy, it's called BECCS, and it's carbon dioxide removal technology, and to meet climate goals by 20, cumulative values of 7.5 billion tons of carbon dioxide may have to be sequestered to BECCS in Europe. So the CCS and BECCS, they are under discussion, and there is technology, but right now it's still quite expensive, and the amounts are not big enough. So this is something which is under very intensive development work, because it's we need this also this in the future. So when we burn this bioenergy, so we anyhow we also produce carbon dioxide, and here this is a study where bioenergy with carbon capture and storage, how much where it could be used and to reach global net zero carbon dioxide emission goals. And this is in Europe, and these are separated as point sources and distributed sources. For points, if we think about this removal of carbon dioxide, of course, it's easier with these point sources where there's a big power plant or something like that, and you can just centralize this collecting and have you have a lot of emissions in one point, and so it's easier to handle. In these distributed sources where this is, there are small amounts of carbon dioxide is produced in small amounts in just in distributed way. So this collecting this emission or treating this emission is more demanding. And this is a bit more information about this BECCS, and Europe, Sweden, Norway, and United Kingdom all have so there is a lot of processes also in Finland developing this BECCS, and the aim of achieving negative emissions to reach the net zero climate goals. So this is just a schematic diagram of this carbon dioxide. So if we start here and use fossil fuels, and they are either combusted just to get heat, or they are used for producing some products or for transport and so on. So then there's an emission of carbon dioxide in the atmosphere, and it's net positive. So there's a positive emission, so coming from these fossil fuels. If we add in these fossil fuels, if we add this carbon capture and storage here, so this carbon dioxide is stored in some kind of well, it might be some caves or just in the some underground containers and so on. So then we can get the net neutrality here. So as much as carbon dioxide is released, it's also stored here. But then if we have this biomass, then it's considered so that this biomass is either it's used for heating, or it's used for producing fuels and so on, and we get these emissions. So we are still net neutral because this biomass is when growing, it is binding carbon dioxide. In the future, this net neutrality it's demanded that the producer must be able to show that this biomass is sustainable, and it's in this red directive. There are the new red directive. There are requirements for that. But anyhow, it can be, the net neutrality can be reached here. But if we then add there also this carbon capture and storage, then the net negative result can be obtained. So that now we are reducing the amount of carbon dioxide in the atmosphere. So, and because there's already seems to be so that the amount of emission, we are not able to reduce the emissions quickly enough. So then this net negative emissions are also needed in order to get the sufficient low level of carbon dioxide in the atmosphere. Then this is only to remind that of course when we look at the carbon dioxide emissions of the bioenergy, we can't only look at this biomass energy conversion, but we have to look at the whole chain. So it has to start with here with this growing of these plants, trees, transport, pelleting, transport, and so on, and so this all this uses all these emissions of carbon dioxide must be added. Of course, in this part here, this is also a carbon sink, so that the more carbon dioxide is bound here than released. So that's a negative part on this chain. What about then this carbon dioxide? So of course one possibility is this storage, so that it's there in some kind of underground cave of container. So, but the better possibility would be to utilize this carbon dioxide, this captured carbon dioxide, and so where could it be used? So one possibility is that when the construction materials they get carbonated, and so they can bind to some extent carbon dioxide. There can be chemical conversion. So if we use this chemical conversion, for example, using hydrogen, hopefully green hydrogen. So fuel chemicals and polymers and commodities can be produced, and these fuels can be methane, methanol, formic acid, synthesis gases, and they can be then refined further to olefins or gasoline and for fuels here. And of course, then this is biochemical conversion. It's also that carbon dioxide can be directed to greenhouses or some algae cultivations where it is utilized, or it can be directly utilized in food and beverages or industrial gas, beverage, working fluids, solvents, and so on. And all this is already possible. Of course, it's it means that maybe it's not yet economically affordable, so that, for example, this production of hydrogen is if we had a lot of for example, excess renewable electricity available, for example, in some very windy or sunny days, so then we could produce by electrolysis hydrogen, and this hydrogen could be used for this chemical conversion of carbon dioxide. But it's still, we are on the way. The direction is good, but we are not there yet. One branch of this bioenergy, this biogas, is something which is already here and it's already used. And in European biogas sector, it's very diverse. It can mean waste management or generating renewable energy, or combination of these two. And for example, Germany generates almost all of its biogas from agricultural crops and crop residues, and United Kingdom on landfill and sewage sludge gases. And other countries, it's a combination of different feedstocks. And this biogas, it's applicable in numerous sectors, in heating and cooling and electricity production and so on. And what is good, it is this production process is major and resilient. It can make use of great variety of substrates. So in that way, when these CCS and BECCS, what I was talking about, they are still under development, and also this chemical conversion. So this biogas is already here, and it can be used. So it's market-ready technology, and almost 20,000 biogas plants operating in Europe, and so it starts here. It can start with the feedstock can be sludge, animal byproducts, household bio waste, and so on. And then we have this anaerobic digest and biogas plant, which in the first case it produces biogas and is digested, which can and when we take these products, this biogas, there are two ways. It can be either directly combusted in these CHP engines for heat and electricity, or it can be upgraded, and this means it can be dry and it can be purified to biomethane, and then it can be used as a traffic fuel. And this digestate, it can be used in organic fertilizer, which can then replace this fossil fertilizer use. So this is about the same. It's this anaerobic. Yes, and this is, well, in spite of this upgrading to methane, it can also, this biomass gasification and methanation can be used, and it can be put here in gas network or used as fuel. So the difference between biogas and biomethane is that this is quite pure methane, and in this biogas there's also some impurities, some carbon dioxide and so on. But for the combustion, you can use also this unpurified biogas. So this anaerobic digestion is well, it's used as in the name, that it's in absence of oxygen, and there's some microorganisms which digest this organic wastes, and there's a mixture of methane, carbon dioxide, and other trace gases. And these are the end products, and this is the biomethane, which this biomethane is one of the most flexible renewable energy carriers, and it can be produced throughout the whole year, and it's very flexible, and right now the situation, for example, in Finland is so that this fossil methane has always been cheaper than biomethane, but now, because of this war in Ukraine, and the situation that we can't import the gas from Russia, so now the biomethane is one of the cheapest fuels one can use in a car. Biogas it's also, it can considered a very important part of the circular economy. So it can return nutrients to farm. It can avoid emissions from landfill, generate renewable energy, and there's a lot of carbon savings can be achieved because of it. And it's also that this permanent storage of carbon dioxide can also be done, of course, with this biogas production, so that then we would have this negative carbon dioxide emissions if we add that also for this production. Another one technology which I wanted to add here is this gasification. This anaerobic digestion is the one which is very much used, and it's well known. And with this gasification process, we can convert dry organic solid substances like lignocellulose biomass, waste, coal, and this can be produced to so-called syngas, producer gas, or wood gas, and that's again it can be converted to methane containing gas, and also to other substances. So the gasification, simple presentation here is that we use here solid fuels and drying and then pyrolysis, and then they are going through pyrolysis. It's done in a high temperature, and we get pyrolysis oil, permanent gas, and char, biochar here, and this pyrolysis oil and permanent gases, they can be go through partial oxidation, it can be reformed and gasificated, and the product here is syngas. And here after pyrolysis we get this biochar, and after this oxidation, besides syngas, there's ash. In gasifying agents, it's water, carbon dioxide, air, and oxygen is used there. And why this gasification and syngas is so important is that this syngas is a mixture of hydrogen, carbon monoxide, and some light hydrocarbons, and the syngas can be converted to fuels, mixed alcohols, methane, hydrogen, ammonium. So gasification has the potential to turn waste disposal into revenue streams for forest food owners and producers, and so this is also a quite it's well known and used technology, and also these gasification plants, they produce not only renewable energy but also this carbon-rich material, for this biochar, which can serve as a stable carbon sink. So this biochar is, there are new products where this biochar is mixed in the soil or in composting processes and so on, and it increases the organic carbon content of the of the soil, and also improves its qualities. With the biogas, so the global food waste alone could produce enough natural gas to satisfy demand of Germany or electricity for over 100 million people, and then there's this livestock waste, and that could produce enough natural gas that is demand both India and China, and so on. So this we already have the technology, and there is a lot of waste which is not utilized. So this, in organizing and investing in this branch, there would be a quite, I don't know if it's easy, but anyhow it's a possible alternative to produce more bioenergy and to reduce emissions, and also to improve the economy for example, in the developing countries. It's also that in Finland we nowadays produced 1 terawatt hour of biogas per year, and the capacity of Finland would be 25. So and now the goal is to increase the production to 4 terawatt hours by 2030, and this is also, this would be very important for Finnish countryside, because there's nowadays a lot of economical problems because of the high prices of energy and high prices of fertilizers, and there's also in some parts there's also a problem how to treat the manure of the cattle and where to put it. So this increasing the amount of biogas would at the same time to solve many problems. So now there is in the climate plans of the given by the government, there's biogas is taken there into account, and now and hopefully there's also money for to help with the investments, because they are needed in order to plan to build the plants. So this is still the top 10 priority countries for biogas, which is this bioenergy World Bioenergy Organization has listed. So there are other big ones, and well, EU is here taken as one unit. So there's also need to use bioenergy in transport, although the electrification is the alternative number one, but the electrificating or the heavy vehicles and so on, it's not easy. So right now the share of energy from renewable sources used in transport in Europe is given here, and here again Sweden is number one, and they're about, well, over 30% is renewable in Sweden. Norway is almost as good, although Norway sells oil to everybody else, but they use these renewable sources. Finland is number 3. It's about 15%, and then the others come after that. So if we don't talk about when we talk about the fuels in transport, so biogas is of course one possibility, but then we must talk about liquid biofuels, and there are two distinct sectors: there's bioethanol and biodiesel. Yeah, and this bioethanol is mainly produced from grains and sugar beet derivatives and wheat, corn, and then this biodiesel, rapeseed oil, vegetable oil, used cooking oil, and so on, palm oil, or palm oil residues. And well, this is a bit more some numbers about the amounts of use, and this bioethanol is mainly produced by the sugar fermentation process, and so as we know, this ethanol is also used for not only for transportation. So this fermentation process is we are familiar with that, but it can be manufactured also by chemical process of reacting ethylene with steam, and the development work in the field of bioethanol is focused on using lignocellulosic or woody material as a feedstock. Bioethanol, it has much lower energy content than gasoline, and that it's that for a given tank volume, the range of vehicle is reduced at the same proportion, but it is very often this biomethanol is fixed with a mixed with a gasoline and used in part as a part of the fuel, not totally with there are also solutions only using biomethanol, and it can be used to replace gasoline, or it can be used for power generation by thermal combustion, and for fuel cells, and also as feedstock in the chemicals industry. Biodiesel is the main biofuel in EU transport, and as I said, this has this rapeseed, soybean, import palm oil, recycled vegetable oil, and animal fat, and it's so the annual production is about 10.5 billion liters. In Finland, we have, well, although Neste is not, it's also not, it's not totally Finnish, well, a Finnish company anymore, but anyhow we consider it Finnish. So Neste is the first company to worldwide produce this biodiesel, and here it's vegetable oils and industrial fats and oil wastes and residues, which are used as a raw material. This vegetable oils, especially with this palm oil, there has been a lot of discussion about this sustainability, because there has been for example, in Indonesia, a lot of wood cuttings for growing more palm trees, but now at least now it's Neste tells that it's mostly it's palm oil residues which are used for this biodiesel production, and all it's only from the certified sites. And then this is industrial fats and oil wastes and residues. This is, well, of course, it's very sustainable source of raw materials. The only thing is that it's not so simple to collect all these materials, and also that there's some kind of limit that how much more of this residue material is available for this production. So just briefly, one can say that this upgrading of waste and residues to hydrotreated vegetable oils, HVO, and this HVO is also known as renewable diesel. And one for all these HVO producers, this sustainable feedstock is one which they have to take care of, and especially because it has to comply as biofuel in European Union. And then this scenario for 2030 about liquid biofuel production. So this is 2020. So we have conventional ethanol, and we have conventional biodiesel, and a little bit advanced biodiesel and biokerosene. And in 10 years, there's a scenario that there's, well, again, ethanol, and this is ethanol with CCUS, captured carbon dioxide, advanced ethanol, same with this conventional biodiesel, advanced biodiesel, and biokerosene, and then it's this advanced biodiesel with also this CCUS. And the amount is, well, it's almost three. It's here forecasted with almost become almost threefold, and this is from International Energy Association, IEA, and European Union forecast that these biofuels produced from organic wastes and residues and with major technologies, so there's a slight increase, and advanced biofuels, there's a steeper growth here, and then renewable fuels of non-organic origin and other eligible fuels. So from here, 1.5% almost to 7%. So represents the percentage they are so high, but this growth rate is quite here quite quick, and the need is there as well. Of course, in transport, we must remember that the electrification is there, the number one, but almost this advanced biofuels are needed. Before we go to this challenges, so I talk some words about biorefineries. So the definition is that the facility that integrates conversion processes and equipment to produce fuels, power, and chemicals from biomass, and this is biorefineries. They are. It's a very fast-growing sector in Europe. So in feedstock, there is either primary biomass or secondary biomass. So this primary is aquatic, lignocellulosic from croplands and grasslands, lignocellulosic food and forestry, and so on, and these are the residues and wastes here. And then the conversion processes, this is biochemical, so there's fermentation or anaerobic digestion, and so what we already. Then there are more exotic ones like insect-based bioconversion and other biochemical conversion. Then chemical catalytic conversion, mechanical and thermochemical, and thermochemical combustion there at the bottom. And this platform here, it is it's the product group where what is used, and then here are the products. And as you notice here, the most products, they are either chemicals or materials or food or animal feed. So these don't directly belong to this bioenergy, but we have here also the bioenergy part. So cooling agents, fuels, heat, power, and other energy products. And very often this energy part is, they are like side streams, side products when producing these chemicals or materials. And in Europe, well, 2020, there were about 140 biorefineries based on chemical pulping. And what did they produce? They produced man-made fibers, pine oil products, and biodiesel and naphtha. And what they were developing is biodiesel and naphtha was also there in this plant side, biochemicals and lignin oil. And this is the category 1, the most common biorefinery based on this lignin or the wood materials. So forest origin feedstocks and facilities based on chemical pulping, and the main product are the cellulose fibers, and then there are side streams, materials, chemicals, fuels, food, feed, pharmaceutical cosmetics, and they can be either produced on site, or then these side streams they can also be sent to these conversion units off site, and here there's this product set is the same as they're in on site part. And the other categories are biorefineries using virgin pulp and recycled fibers, and other and biorefineries using lignocellulose as a raw material. And well, here the text is a bit small, but hopefully you can read it when. So here this one biorefinery we are very proud of is this Äänekoski industrial business ecosystem, and here we have a very versatile products, processed food products, paper and board. These are the main products. Then of course pulp, and then cellulose derivatives and wood-based chemicals, and these cellulose derivatives can be a quite a important thing in the future. Then bioenergy is electricity, heat, biogas, and biopellets, and chemicals and fertilizers and other raw materials. So it means that those substances which in earlier years went to this black liquor and were burned and they were used for energy production, they can also now be used for material and chemical production, which are, and their value it's in that form it's much higher, although this bioenergy is also important for us. Now there was a piece of news that this Metsä Fibre and Veolia recently signed a long-term partnership agreement on refining crude methanol generated in pulp production at Äänekoski, and this methanol is a very very important material for fuel production, for biofuel production for transportation. So, and this is now the world, as I understood that it's there's one plant in Sweden, but this is going to be the biggest in the world producing this biomethanol. And now, well, we have gone through this, just the main products and maybe the some main points in this technology development. And then the last thing are these challenges, supply, demand, and sustainability I'm going to talk about. So if we think about the role of bioenergy in the future, so bioenergy is key to achieving EU targets in terms of renewable energy by 2030. So it's very important. And and the opportunity to increase the utilization of bioenergy in fields of using agricultural residues, byproducts, and waste. And another thing is that bioenergy can also play a significant role as a flexible energy carrier that balances power and heat systems, and allowing higher shares of renewable energy sources as wind and solar power. This is well, more detailed suggestions from International Energy Association for reaching net zero emission targets, but I leave them for you to read in more detail. Maybe the main challenge is what I have already talked about, is that this is the scenario in 2050 biomass supply and demand. And demand in current climate scenarios is this is the bioenergy demand and material demand. And this is the available supply: forestry, agriculture, and waste. And there's quite a big gap in EU. And now this increasing bioenergy would be like an easy solution for many questions, many challenges, but this is the situation that this supply can't answer all the needs. And material uses will be particularly high value areas, and traditional bioenergy applications are set to become less competitive, and future high value uses of bioenergy instead are found highly specialized uses. So, and carbon management can add additional value here about this CCS and CCU, what we have a little bit looked at. So besides this gap, so this sustainable use of bioenergy requires that overall life cycle of greenhouse gas emissions are well below those of fossil fuels. So as I shown in one of these slides, is that the whole life cycle has to be taken into account, not only the energy production site. And aspects like cultivation of biomass, transport, processing, or potential changes of the carbon stock need to be taken into account. So it's also it's not so simple that this bioenergy is always has no emissions at all, but they have to be looked at a little bit more detail. And more challenges is that this climate change poses challenges to European forestry and biomass sector. So this growth, there are some risks for the growth of forests and also the cultivation. And the findings show an urgent need to prioritize future biomass use, and current hopes for increased use of far exceed realistic sustainable increases in supply. And biomass will play a valuable role in future materials and chemical production, and in some aspects in energy supply, but it's not a common, it's not a general solution for all the new needs. So the benefits is that it's answers to this renewable energy source targets, and it improves energy security, and it's storable renewable energy with this wind and solar energy, the problem is this storing of the energy, and here this is storable, which is a good thing, and it can help in grid balancing. And it has the climate benefits compared to fossil fuels, and it's also it can contribute to growth and jobs, and especially in rural areas which may need some support in the economy. So risks are there: climate performance of certain biofuels and forest biomass pathways. This is indirect land use impacts of biofuels from food and feed. So there might be also environmental impact for biodiversity, air quality, and soil. Then competition with other biomass using sectors. So here is this material and food, and low efficiency of biomass electricity conversion. So for electricity conversion, it's not the best possible alternative. And well, there were already these strengths and weaknesses. There was an aspect of sustainability, but if you think about the positive things, is that of course the reduction of fossil fuel energy dependency, addition to value to local agriculture and forestry inputs, and development of circular economy, and create some job opportunities, and contribution to reduce energy poverty by offering the affordable renewable solution. For example, here is this utilization of this food waste, for example, for producing biogas and so on. It could answer to this. Promotion of local development and so on. And contribution to achieve EU carbon neutrality, creation of new uses for waste and boosting of circular economy, mitigation of greenhouse gas emissions, and improvement of forest management, lowering the impact of climate change disturbances. Yes. But then there's the bioenergy use is high and rising. An increased demand for forest biomass means more intensive forestry, and more intensive forestry means or can mean less biodiversity, and protected areas and primary forests are at risk. So these are some claims against this increasing use of bioenergy, and these are some set of questions. What FAO is when they are starting some bioenergy project, so they ask in the communities, and in order to find the ways to go on and to find the weak points. The main thing EU is trying to answer to this sustainability is this renewable energy, this new renewable energy directive, and this revision, which is right now, which has been given and which is under discussion in European countries and European Union. EU has also given a biodiversity strategy for 2030, and comprehensive, ambitious long-term plan to protect nature and reverse degradation of ecosystems, and this, it has 3 targets concern the network and nature protection areas. So increasing the surface area protected so that minimum of 30% of EU's land area and 30% of the EU's sea area covered by legal protection. strictly protecting at least a third of the EU's protected areas, including all remaining primary and old growth forests, and more effective management of all protected areas. And well, these are good targets, of course, in the countries like Finland, where we have a lot of forests and we have at least our own opinion that we have protected quite a large part of them. So it's not always found so easy to find where to increase this protection, but it is needed, and hopefully it's done throughout the Europe. So because this biodiversity, we have the signs that we have to work for it, so that to protect the species and protect the nature. Then here at the end, I want to say that because we have already partly overstepped on this planetary boundaries, so I think bioenergy is one of good answers of that, but we have to use it in a very clever, very wise way, and we have to find the ways how to limit our consumption and how to be energy and material efficient, because we can't forget that part. Then there are some, well, there's a lot of material available about this bioenergy. Here I have just listed four reports, which I think are quite good and quite good presentations of the topic. If you want more information on this bioenergy and its future. Okay, I stop here and thank you.